Hello friends. So now in this video we are going to start our very first sorting algorithm, which is insertion sort algorithm. Okay, and this is the first part of this insertion sort algorithm, as we have discussed in the introductory class of the sorting algorithms, that we are going to have 4 to 3 parts for learning each sorting algorithm. First part will consist the idea behind the sorting algorithm, and the next part we'll see that what the algorithm actually is, and after that we'll see the pseudocode, and finally we'll see the analysis part, which is the most important part of each and every algorithm. Okay, so now let's get started with the insertion sort algorithm. Okay, so I will introduce you with the insertion sort algorithm with the help of one problem, and I will show you that how insertion sort algorithm works step by step, right? So we'll first solve one problem. Okay, so let's say I have an array A, right? So let's say I have an array A whose size is, say size is, so size is, let's say n, right? Okay, so n size we have. Now the condition on the array is such that it follows this condition, like a0 is less or equals to a1, is less or equals to a2, is less or equals to a3 dot dot, is less or equals to an minus 1. So do note here that the condition says that oh look, you have an array of size n whose name is a, and according to the condition here, you can see that this array is sorted until n minus 1 elements, right? But there is no any condition on the nth element. That means actually you have an array and n minus 1 elements are sorted, but due to the last element, which is a of n, your whole array has become unsorted. Now your task is to sort the whole array, right? So task is to sort the array A, right? So let's take example to understand this problem completely, right? So let's say you have an array like 2, 4, 6, 8, 10, right? And and at last you have 1, right? So if you do note here, the size is how much? 6 elements, right? Okay, so according to this condition, your 5 elements, right? So it should be n minus 2, right? N minus 2, because it's 0 based indexing, right? Yeah, so for n equals to 6, starting from 0, the 5 elements will be sorted. As you can see, these 5 elements are sorted, but due to the last element, okay, the whole array has become unsorted. So your task is to sort this array. That means you have to just put the last element at the appropriate place inside this array, such that this array becomes sorted. Okay, so this is the problem. Think about it. Pause the video and think about it. Okay, and come back. So I hope you have tried it. So let's see here that how we can do this, how we can solve this problem. Okay, so to solve this problem, the logic is that what you have to do is that you just store this last number, right? Last number of the array. Say a of n minus 1 is the last element of the array, if we consider the 0 based indexing, right? So consider this last element and store it in some variable, say key. Okay, you have stored it with variable key. Now what you do, you shift all the elements which are greater than the key, that means the last element, to the right by 1 place. So you have to shift all the elements which are greater than 1 to the right by 1 place, right? That means if you see, if you apply the algorithm that we are going to discuss, the final array should be 1, 2, 4, 6, 8 and 10. So what have you done here? You have just taken this one and you have shifted all the elements which were greater than the 1 to the right by 1 place. So if you do note here, its index is 0, 1, 2, 3, 4 and 5, 4 and 5, right? So here its index is 0, 1, 2, 3, 4 and 5. If you do note the indexes difference, you'll find that the index difference is increased by 1. All those whose value were greater than the key, right? So now let's write the code to understand this, right? So we'll write this code in a better manner. So what we have discussed till now is that let's try with the black marker. It's not working right now. Okay, so let's see. So array was 2, 10. Let's leave it. So 2, 10, not 10. 2, 4, 6, 8, 10 and 1. This was my unsorted array. Now we want it to get 1, 2, 4, 6, 8 and 10, right? Yeah. And so the code, let's see. So first, as I have told you, let's say I do have function, say sort, right? Sort. Let's say function is sort, in which I am passing a parameter. First one is the array, right? So array A, whose name is A, and size is here, and int n is the size, right? So I am passing this into this function. Now what I want, I will first declare one variable, let's say int key equals to 0, and inside the key I will store my last element, because only due to the last element the whole array is becoming unsorted, but from 0 to n minus 2 elements, that means n minus 1 elements are already sorted. So you just have to place it in the correct position. That's what we have discussed right now. Okay, so now let's see here, after storing this, what you need to do, this has been stored in key value, right? Now take one more variable, say as you have to iterate through each element and compare with the key value, and you are going to compare with the each key value, and if you find that this element is greater than the key value, then you are going to set that element. So that's why we need one more variable I, right? So that will be in for loop. So let's say I have for loop and I do int I equals to, I have to start from where? N minus 2, right? Do note here, I have to start from n minus 2. Okay, and after that I will put the condition that I should be greater or equals to 0 according to this, and finally I will decrement the value of I, right? And inside this I will write my next code. So do note here what we're going to do. Yeah, so take this here, 2, 4, 6, 8, 10 and 1. So if you do note here, this is my initial I and this is key, it has been fixed, right? So you are going to compare, right? So you will compare A of I with key, and if you find that if this is the case, then what you're going to do, you're going to shift this 10 to the next position. That means you're going to do A of I plus 1 to A of I, right? By doing this, the array that you will get is, after first iteration, is something like this, right? Get it? Okay, so do note that we have not lost our 1. We have stored it in key variable. Okay, so I do have this value stored somewhere in the variable, right? So again, when the I value will be decremented, now I will be here, key value will remain same. Again, I will do the same steps here. I will come back and do the same step. If I find that it's greater, which is greater in this case, I will again shift this to the right position. That means after next iteration, what you will find? 2, 4, 6, 8, 8 and 10, right? You will find again you do the same, because I value has been again decremented, so it will come here, right? Again it will do the same stuff, again it will come back. So from here you will get like 2, 4, 6, 6, 8, 10. If you go on doing this, you will get 2, 4, 4, 6, 8, 10, right? And if you go on doing this, again you will get something like 2, 2, 4, 6, 8, 10. Okay, at last iteration, when your I value will become negative, right? I will be pointing to -1. Okay, so what you're going to do is that let's erase it, right? So when you get this part, when you come to this part, 2, 4, 6, 8, 10, and the I value will be pointing to -1, right? So once the I value will become negative, then what we're going to do, we're going to do A of I plus 1 to key. That means now we are going to assign the value of key to its right position. That means we have find the right position. Right position is I plus 1, right? So if you do this, then the next array that you will get is like this. Okay, so I hope you have understood the process here. Okay, so this is how you got the sorted array. Okay, so now let's focus on the code here and erase this part. Okay, so let's focus on the code here. So as I have discussed that I will see the condition that if A of I is greater or equals to say key, then what I am going to do is that, oh look, I am going to shift the element at the ith place by one place to the right, and at the same time I will decrement the value of I, right? So this is the if, okay, and this is this, right? Else if you find something, So after this I will decrement the I value, okay, and in the else part, if I find that this case has not been found, then I will say break from this, okay. And once you come out of the for loop, what you have to do, you have to do a of I plus 1 equals to key, right? So I will assign a of I plus 1 equals to key. So and at last I will do return, right? So this is the code to implement this. Now let's take one more example and go through this code, okay. So let's see, I took one more example, say 1, 4, 8, 10 and 2, right? So you see the value of n has now become from 6 to 5, and if you see again the 4 elements is sorted, first 4 elements is sorted, but due to the last element the whole array is become unsorted, okay. So how we are going to sort this? So first iteration, I will store this value in key, right? After storing this value in key, I will run a for loop from here. After running the for loop, I will check the condition that if a of I is greater or equals to key or not. So in this case, I am checking the condition that 10 is greater or equals to 2 or not. So this condition is satisfied. It will come inside and it will assign this, right? So if it will assign this, the array that you are going to get is something like this. So this is my array after first iteration, right? Again, the I value will be decremented. So initially I was here, now I has become here. Now again it will go on to the for loop. Again it will check the same condition. That means here the condition will be checked something like it is greater or equals to 2 or not. It will find that condition is correct. Again it will do this. Okay, so you will get the array like this: 1, 4, 8, 8, 8 and 10. And the I will become here. I will come here. Again if you do the same stuff, then you are going to do 1, 4, 4, 8 and 10. Okay. And now I has come here. Do note, again for loop will come and it will check the condition ai is greater or equals to key or not. That means basically you are checking the condition that if this is true or not. So this is not true, right? So again, so hence it will not execute the if part, it will execute the else part. So else part is saying that you break from here. That means you come out of the loop, it will come out of the loop, and you do have a here. And what you have to do once you come out of the loop, you just assign a of I plus 1 value as key, right? So that means once you find an element which is less than the key value, okay, so you got the place, you got the exact position from where you need to insert the key value. So here the position that where I need to put the key value to make the array sorted is nothing but it's I plus 1. That's what we are doing here. So finally when I come out of the loop, I am going to say that, oh look, I have found the exact position where 2 should be inserted, and that position is a of I plus 1, and that's what I am doing. I am assigning the value of a plus 1 equal to key. So if you do this, the final array that you are going to get is something like 2, 4, 1, 2, 4, 8 and 10. Okay, so this is sorted, right? So this is the basic idea of the insertion sort algorithm, and we'll see that what the actual insertion sort algorithm in the next video, which is part 2. I hope you have understood this problem, and make sure that you have understood this problem properly, because we are going to use this problem in a recursive manner, right? So in the insertion sort, we'll be focusing on the small arrays, and we'll be sorting the small arrays using the approach of recursion. Okay, so that's why I have given this problem to you, so that you understand the basic logic behind this. And once you understood this, then it will be very easy to understand the insertion sort algorithm. Okay, so I hope you have understood all this concept. If not, then you can comment in the comment box, or either you can go through the same video. And if you are not able to understand my handwriting, then sorry for that. I will try my best to improve my handwriting, right? Okay, so that's it for this video. I hope you have understood it completely. See you in the next video with the insertion sort algorithm, what the algorithm basically is. Okay, so that's it for this video. Thank you and Jai Hind.